This is SpaceTime Series 20, Episode 25. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, YouTube, Audio Boom, direct from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world through TuneIn Radio, and as in-flight entertainment aboard Virgin Australia. Coming up on SpaceTime, discovery of a new type of star formation, the spectacular pillars of destruction in the Carina Nebula, and electric sands discovered on the Saturnian moon Titan. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a new way to produce stars. A report in the journal Nature claims scientists with the European Southern Observatory have found stars being formed in the powerful outflows generated by supermassive black holes. This discovery means black holes don't just destroy stars, they can also create new ones. The findings are the first confirmed observations of stars forming in this kind of extreme environment. The discovery has many consequences for science's understanding of galaxy properties and evolution. The study's lead author, Roberta Maialino from the University of Cambridge, says astronomers have thought for a while that the conditions inside these black hole outflows could be right for star formation. But no one had ever actually witnessed this happening before because it's such a difficult observation to make. Maialino says the new results are exciting because it shows unambiguously that stars are actually being created inside these outflows. Astronomers made the discovery while using the VLT, or Very Large Telescope, in Chile to study an ongoing collision between two galaxies known collectively as IRAS F23-128-5919 and located about 600 million light-years away. Maialino and colleagues are observing the colossal winds of material being spewed out by the supermassive black hole at the heart of the pair's southern galaxy. During these observations, they detected the first clear evidence that stars were being formed in these outflows at a very rapid rate. In fact, the team estimates that stars equivalent to some 30 times the mass of our Sun are being formed in these outflows every year. That compares to just a single solar mass worth of new stars being born in our own Milky Way galaxy every year. This huge star formation rate accounts for over a quarter of the total star formation rate in the entire emerging galaxy system. The galactic outflows producing this starburst activity is being driven by the huge energy output from the active and turbulent centers of these galaxies. Supermassive black holes are thought to lurk at the cause of most, if not all, galaxies. As they gobble up any matter that ventures too near, huge amounts of energy material is released before the doomed object passes inside the black hole's event horizon, the point of no return, beyond which nothing, not even light itself, can escape, and is thus fated to fall forever into the black hole's singularity, a place where science's understanding of the laws of physics breaks down. This superheated outflow also heats the surrounding gas and expels it from the host galaxy in powerful dense winds. This expulsion of gas through galactic outflows, known as quenching, leads to a gas-poor environment within the galaxy, which could be why some galaxies cease forming new stars as they age. Although these outflows are almost exclusively driven by massive central black holes, it's also possible that the winds could be powered by supernovae in a starburst nucleus undergoing vigorous star formation. That's because really big stars are like James Dean. They live fast and die young, exploding as powerful core collapse supernovae. The authors had originally set out to study stars in the outflow directly as well as the gas that surrounds them. By using the VLT's powerful Muse and X-shooter spectroscopic instruments, they were able to undertake a very detailed study of the properties of the emitted light in order to determine its source. You see, radiation from young stars is known to cause nearby gas clouds to glow in a very particular way. The extreme sensitivity of X-shooter allowed the authors to rule out other possible causes for this illumination, including gas shocks or the active nucleus of the galaxy. It was then when the group made their unmistakable direct detection of an infant stellar population within this outflow. This was achieved through the detection of spectroscopic signatures characteristic of young stellar populations, and with a velocity pattern consistent with that expected from stars being formed at high velocity in the outflow. These stars are thought to be less than a few tens of millions of years old, and preliminary analysis suggests that they're both hotter and brighter than stars formed in less extreme environments, such as the galactic disk. The authors were also able to determine the motion and velocity of these stars. The light from most of the region stars indicates that they're travelling at very high velocity away from the galactic centre. Of course, all this makes perfect sense if you're looking at objects caught in a stream of fast-moving material. The stars that form in the wind close to the centre of the galaxy may eventually slow down and possibly even start heading back inwards under the pull of gravity. However, stars that form further out in the flow would experience less deceleration, and that means they could even fly off out of the galaxy altogether. And that offers some interesting possibilities. This discovery provides new information which could better science's understanding of some key areas of astrophysics, including how certain galaxies obtain their shapes. See, spiral galaxies, such as the Milky Way, have a fairly obvious disk-like structure, with a distended bulge of stars in the centre and surrounded by a more diffuse cloud of stars called a halo. The other major type, the elliptical galaxy, is composed mostly of these spheroidal components. And outflows of stars that are being ejected from the main disk could well give rise to these galactic features. These findings could also help astronomers work out how intergalactic space becomes enriched with heavy elements. How this space between the galaxies, known as the intergalactic medium, becomes enriched with heavy elements is still an open issue, but outflow stars could well provide the answer. See, once they're jettisoned out of the galaxy they were born in, then when they explode as supernovae, the heavy elements they contain could be released into this intergalactic medium. The discovery could even provide clues about where the unexplained cosmic infrared background radiation comes from. Cosmic infrared background radiation, similar to the more famous cosmic microwave background radiation, is a faint glow in the infrared part of the electromagnetic spectrum that appears to be coming from all directions in space. However, its origins in the near-infrared bands are a mystery. A population of outflow stars being shot into intergalactic space could provide a contributing factor for this light. So, if star formation really is occurring in most galactic outflows, as these theories are predicting, then this would provide a completely new scenario for science's understanding of galaxy evolution. You're listening to SpaceTime. I'm Stuart Gary. Spectacular new observations of vast pillar-like structures within the Carina Nebula are providing astronomers with new insights into just how ephemeral these giant features really are. A report in the monthly notices of the Royal Astronomical Society are showing a strong link between the rate at which these pillars are being destroyed and the amount of radiation being emitted by the stars that were being formed by these pillars in the first place. The spires and pillars in the new images have been named as the Carina Nebula's Pillars of Destruction. They're vast molecular clouds of gas and dust, each several light years long, and located in a star-forming region some 7,500 light years away. The pillars were observed by scientists using the European Southern Observatory's VLT, or Very Large Telescope, in Chile. The authors created thousands of images of 6 of the Carina Nebula pillars simultaneously, each at different wavelengths. This allowed them to map out the chemical and physical properties of the material at different points in the pillars. The team then compared their observations of the Carina Nebula with observations from 2 other nebulae, the famous Pillars of Creation in the Eagle Nebula and formations in NGC 3603. The Pillars of Creation in M16, the Eagle Nebula, are located some 6,500 light-years away and are one of the most iconic images ever taken by NASA's Hubble Space Telescope. The 3 towering spires of cold molecular hydrogen gas, dust and newly forming stars are each about 4 light-years long. The Pillars of Creation may already have been blown away by what's thought to be a supernova shock wave from a nearby star that exploded and died. Astronomers speculate the shock wave crashed into and destroyed the Pillars of Creation some 6,000 years ago. Now, given their distance from our solar system and the finite speed of light, this destruction won't be visible from Earth for another 500 years. As to the other nebula, NGC 3603, it's one of the most massive young star clusters in the Milky Way galaxy. It contains thousands of sparkling young stars nestled inside a stellar jewel box. It's a prominent star-forming region in the galaxy's Carina spiral arm, located some 20,000 light-years away. The authors found clear links between the radiation emitted by nearby massive stars and the features of the pillars themselves. In an ironic twist, one of the first consequences of the formation of a massive star is that it starts to destroy the very molecular gas and dust clouds from which it was born. The idea that massive stars have a considerable effect on their surroundings isn't new. Such stars are known to blast out vast quantities of powerful ionizing radiation, emission with enough energy to strip atoms of their orbiting electrons. The problem is it's been really difficult to obtain observational evidence of the interplay between such stars and their surroundings. The authors in our study were able to analyse the effects of this energetic radiation, known as photoevaporation, on the pillars. They found that the pillars were being destroyed as the molecular gas and dust in the nebula is ionised, evaporated and blown away. By observing the results of photoevaporation, the team were able to measure the mass loss of these pillars, finding a clear correlation between the amount of ionising radiation being emitted by nearby stars and the dissipation of the pillars. Until now, the complexities of the feedback mechanism between stars and the pillars was poorly understood. But by combining observations from 10 different structures in 3 different nebulae, instead of just analysing a single nebula, the authors were able to determine the quantitative connection between ionising massive stars and their impact on the surrounding nebulae which originally gave birth to them. Interestingly, these nebulae have average densities of less than 1,000 particles per cubic centimetre. So while these pillars may look solid and fairly dense, the clouds of gas and dust making up the nebulae are actually very diffuse, with densities even lower than fog or smoke on Earth. It seems they only appear solid because of their impressive size. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
We are looking at some new observations of the Carina Nebula. So tell us about the Carina Nebula, first of all. It looks amazing.
It is. It's one of the most spectacular regions of the whole southern sky. And by the way, the Carina Nebula for us here in New South Wales passes directly overhead once a day. Pillars of destruction are going past all the time. That's as the Earth rotates, of course. So a nebula is the term as we use it now is a cloud of gas and dust. The term originally comes from the, probably Greek actually, word for mist. A nebula is a mist because people saw misty things in the sky. They weren't stars, they weren't planets, so they were nebulae. That was the other thing that early astronomers saw and hence gave them the name of a nebula. The modern knowledge of nebulae is that they are actually gas clouds which are laced with a lot of dust, I suppose in the similar vein to smoke. It's, smoke like dust is probably the best way to put it. We know also that these are the birthplaces of stars. It's where stars are born. And you and I will remember from the very earliest days of the Hubble Space Telescope back in the early 1990s, one of the earliest images, and a very dramatic image that it sent back, was of a region of the Eagle Nebula that had these 3 fingers of dark material, which are very concentrated regions of dust in an area of dust and gas, the Eagle Nebula itself. That picture was termed the Pillars of Creation. And the reason for that was that the centers, the sort of tops of these pillars actually contain stars which are just coming into being. We can see them when we penetrate the dust with infrared telescopes that are looking at the redder than red region of the spectrum. You can't see them with an ordinary optical or visible light telescope. So the Pillars of Creation have become really part of our folklore in the world of astronomy. And that's why it's a bit of a contrast to see this, what looks at first sight rather similar, pillars of dark material against a bright nebulous background, but these are being called the Pillars of Destruction. And this is some research that's come from the European Southern Observatory, whose telescopes are down in Chile. The astronomers are actually based near Munich in Germany, and it's a group from there that has analysed this region of the Carina Nebula and worked out that yes, these pillars that we see are actually basically being destroyed, because what's happening is that there is a group of young energetic stars which have recently been born in the Carina Nebula, and their radiation is basically blasting into these clouds of dust and turning them into pillars, sort of sweeping them away and destroying them as these stars actually come into the first flush of youth.
So they are aptly named. It wasn't just a name because there was one that said the opposite. There is actually destruction happening.
It's destruction happening, at least in terms of the structure that we see there. How do they know that? How are they inferring this from the images? Well, that's because they've used an instrument that's a bit cleverer than just taking pictures. It's something called MUSE, which stands for the Multi-Unit Spectroscopic Explorer. Work that one out. But what it does, if you imagine a picture of the area, and you can go to actually the European Southern Observatory's website and see beautiful images of these pillars of destruction. If you imagine a picture of that and then say, well, for every point on that picture, we can see a spectrum, the rainbow spectrum of that point. And that, of course, has a barcode of information in it that's telling you what the materials are that are there. It's mostly glowing hydrogen, but there's other things as well. How fast it's moving, that's the key thing, how it's moving through space. And when you combine all this information, you can actually analyze that, yes, these pillars are being blown away basically by the energy of the stars nearby. So it is aptly named, and it's a very dramatic region of the sky. And as I said, it goes over our heads once a day.
Oh, wow. During the day or during the night?
Depends on the time of year.
So if you know what you're looking for, you'd see it?
You would actually. The Carina Nebula is one of the ones visible to the naked eye. It's actually best visible in our wintertime, in fact.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. You're listening to Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. A new study has found that sands on the Saturnian moon Titan are highly electrically charged. The findings, reported in the journal Nature Geoscience, helps explain unusual features seen in Titan's landscape. The study's lead author, Josh Mendez-Harper from the Georgia Institute of Technology, says the electrostatic forces in Titan's sand grains are so strong, only really heavy winds could move them. Mendez-Harper and colleagues reached their conclusions after carrying out experiments on simulated Titan soil. They discovered that the particles covering the surface of Saturn's largest moon are electrically charged. When the wind blows hard enough, over say 24 kilometers per hour, Titan's non-silicate granules get kicked up and start hopping across the surface in a motion known as saltation. The same thing happens with sand grains here on Earth. But unlike the Earth, on Titan when these grains collide, they become frictionally charged. This electrostatic charge causes these particles to clump together in a way not observed for sand dune grains on Earth. Thus, the electrostatically charged grains on Titan become resistant to further motion. And they can maintain that charge for days or even months at a time, and then attach to other hydrocarbon substances, much like packing peanuts used in shipping boxes here on Earth. Georgia Tech professor Josef Dufek, who co-authored the study, says if you grabbed piles of grain and built a sandcastle on Titan, it would probably stay together for weeks due to the grain's electrostatic properties. So any spacecraft that happens to land in regions of granular material on Titan's surface would have a tough time staying clean. The electrification findings may help explain an odd phenomenon on the Saturnian moon. You see, prevailing winds on Titan tend to blow from east to west across the moon's surface. But sandy dunes nearly 100 metres tall seem to form in the opposite direction. It seems these electrostatic forces are increasing frictional thresholds, making the grains so sticky and cohesive that only really strong winds can move them, and the prevailing winds simply aren't strong enough to shape the dunes. To test particle flow under Titan-like conditions, the authors built a small experiment in a modified pressure vessel. They inserted grains of naphthalene and biphenyl into a small cylinder. Naphthalene and biphenyl are two toxic carbon and hydrogen-bearing compounds believed to exist on Titan's surface. The samples were then rotated in the cylinder for 20 minutes in a dry, pure nitrogen environment. Titan's atmosphere is composed of 98% nitrogen. Afterwards, the authors measured the electrical properties of each grain as it tumbled out of the cylinder. Up to 5% didn't come out of the tumbler at all. Instead, they clung to the inside and stuck together. When the authors repeated the same experiment using earth sands and volcanic ash in Earth-like conditions, all of the grains came out. Nothing stuck. Mind you, earth sand does pick up electrical charge when it's moved, but the charges are far smaller, and they dissipate quickly. That's one reason why you need water to keep the sand together when building a sandcastle on Earth. But not so on Titan. These non-silicate granular materials can hold their electrostatic charges for days, weeks, or even months at a time under low gravity conditions. It's interesting because visually at least, Titan is the most Earth-like world in our solar system. Data gathered from multiple flybys by NASA's Cassini spacecraft and its Huygens lander have revealed a world with large liquid lakes at the poles, as well as mountains, rivers, and potentially volcanoes. On Titan, they're composed of methane and ethane and are replenished by rains from hydrocarbon clouds. On Titan's surface, the only water is ice, and it forms much of the moon's bedrock. Titan's surface pressure is also a bit higher than that on Earth, so standing on Titan would feel similar to standing 5 meters underwater. The findings mean Titan's extreme physical environment requires scientists to think very differently about what they've learned from Earth's granular dynamics. Put simply, Titan is a strange electrostatically sticky world. Its landforms are influenced by forces which aren't intuitive to people on Earth, and that's because those forces aren't so important on Earth. I'm Stuart Gary, and this is SpaceTime. And finally for now, NASA's Juno spacecraft has successfully completed its 5th close flyby of the Jovian atmosphere. Mission managers say the probe's cameras and all of its 8 scientific instruments were operational during the close encounter, gathering information about the gas giant's cloud structure, gravitational and magnetic fields, and its auroral activity. At the time of closest approach, known as perigove, Juno was just 4,400 kilometres above the planet's swirling cloud tops, travelling at some 57.8 kilometres per second. Juno's principal investigator, Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says every time the probe swoops low over Jupiter's clouds, scientists get new insights which help them better understand the solar system's largest planet. Although not a star, Jupiter actually generates more heat than it receives from the Sun. In fact, were it a little bit bigger, it would probably be a brown dwarf. Meanwhile, Juno's science team are continuing to analyse data returns from previous flybys. Scientists have already discovered that Jupiter's magnetic fields are far more complicated than originally thought, and that the belts and zones which give the planet's cloud tops their distinctive look extend deep into its interior. Observations of the energetic particles that create Jupiter's incandescent auroras suggest a complicated current system involving charged material lofted from volcanoes on Jupiter's moon Io. During these flybys, Juno's probing deep beneath the obscuring cloud cover of Jupiter in order to learn more about the planet's origins, structure and atmosphere. Juno's mission's also measuring Jupiter's composition, gravity, magnetic field and polar magnetosphere. The data will allow scientists to better understand how the planet formed, including whether it has a rocky core and a long hypothesized metallic hydrogen mantle. Juno will also try to determine the amount of water present in Jupiter's deep atmosphere and its deep winds, which reach speeds of over 600 kilometres an hour. Peer-reviewed papers with more in-depth science results from Juno's first flybys are expected to be published within the next few months. Juno was launched back on August 5, 2011 from the Cape Canaveral Air Force Base in Florida. The probe achieved Jovian orbit insertion on July 4, 2016. During its mission of exploration, Juno soars low over the planet's cloud tops, as close as 4,100 kilometres, before swinging back out and beyond Jupiter on a highly elliptical and eccentric orbit, designed to avoid as much of Jupiter's powerful radiation belts as possible. The probe also contains a special radiation-resistant compartment or strongbox, where most of its delicate electronics are mounted in order to further minimise radiation exposure and damage. After completing its mission, Juno will be intentionally deorbited into Jupiter's atmosphere so as not to risk contaminating the ice moon Europa, which contains a global subsurface liquid water ocean which theoretically could contain life. Juno's next close flyby of Jupiter will occur on May 19. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important, or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.